Hello, everyday statistics, and welcome to lesson 2.6. We're going to talk about the least squares regression line today and how to calculate that using our technology. All right, let's get right into it. Today, we're going to calculate the equation of the least squares regression line. We're going to use summary statistics, and we're going to talk about outliers. Probably stick to the technological, I guess I should say, approach to this as well. So our least squares regression line makes the sum of the squared residuals as small as possible. Well, let's talk about what that looks like. So remember, we said that our residual is our observed or our actual value minus our predicted value. And you can see that it would make sense to square those so that we wouldn't wind up with some negative values. We're trying to create a line, right, that is as close to each point as possible. That's the point of looking at the squared residuals. It creates a line that fits the data best, especially when we're dealing with linear data. So if we're using some summary statistics, you would be given your R value. You would get the standard deviation of Y, standard deviation of X. That will give you your slope. And then in order to find our y-intercept B, we would use our slope that we calculated up here. We'll use the mean of our y and the mean of our x. We're going to go ahead and do that here in a little bit, all right? And so we also need to talk about outliers. Outliers are going to affect the slope of our least squares regression line quite a bit. So check it out. What we've got is child 18 over here, right? Child 18, you can see, right, is dropping this slope, right? It's dragging the line towards it, right? If we take that child 18 away, you can see this blue line is going to have a slope. It's going to have less of a slope because that point is taken out. If we look at child 19 over here, child 19 is not as extreme of a value, right? But you can see that that it does have an effect on the slope. We can see all of these different regression equations. Let's go ahead and work on this. Let's look at the Denver Broncos. We got a scatter plot showing the relationship between passing yards and points scored for 32 NFL teams in 2013. Broncos set the NFL record. So which one do you think is them? I think that this is the Broncos. What do you think that that's doing to the slope of the least squares regression line? Well, it's probably dragging it up towards it. Let's go ahead and get an example done for you. So we've got a mean. Let's go ahead and write this thing down. In the information, it says for passing yards, the mean is 3,770 yards. So passing yards, it says, is our x, right? So if it says for passing yards, the mean is 3,770, what they're telling us is that x bar is equal to 3,770. And it's telling us that the standard deviation of x is 594. It tells us that for points scored, so look at that, that's our y. The average is 375. While the standard deviation of y, it says, is 70 points. So it differs from the mean on average by about 70 points. The correlation we've been given is R equals 0.616. Let's use this information to calculate the equation of the least squares regression line. So in order to do this, we're going to need a couple of equations there. We've got our statistics that were given in the problem. Let's go ahead and calculate the least squares regression line. Y hat equals bx plus a. All righty then. So the first thing we need to do is figure out our slope. B is equal to R, which is 0.616 times standard deviation of y, which is 70, divided by the standard deviation of x, which is 594. We'll go ahead and put that in our handy dandy calculator and get a value, which turns out to be approximately 0.073 if we round to the thousandths place. All right, let's go ahead and find our y-intercept, which is A. So that is going to be y bar, or our mean of our y values, minus our slope, B, which we just calculated, times the mean of x, our x values, which is 3,770. Let's go ahead and calculate that value, which is going to turn out to be 99.79. So we're almost done. Now it's time to plug that in here. So it says B is 0.073 times x plus A, our y-intercept, which is 99.79. And there we go. We have calculated the least squares regression line using some summary statistics. Let's also do this using some technology. So here's our next example. We've seen this one where we're talking about sugar versus calories. Let's go ahead and use this table and our calculator in order to create a least squares regression line. We are going to do this using our TI-84 Plus calculator. So what we're going to have to do is get out our calculator and hit the Stat button. From there, we'll select Edit and fill in these lists. So L1 is going to be all of our x values, which is sugar, our explanatory variable. We'll put those in. And I believe this one is Reese's. Some Skittles. Excellent. So now we've got our explanatory variable in. Let's go ahead and enter the values for our response variable are calories. So for 50, just going through the list and working it out. Hey, maybe if I can do two things at once, it's time for a joke. Hey, what is Snoop Dogg's favorite weather? It's drizzle. That's right. All right. 680, this is for sweet tarts. 460 was for Twizzlers, and then 350 calories in some Whoppers. Again, I'm just going to go through this and check to make sure that each value matches up. So I want to make sure that 79 goes with 790, just to make sure that I didn't make a mistake. I'll pick a few at random, right? 92 goes with 490, just making sure that I didn't make any errors, because that would definitely give me an incorrect answer. So once I'm there, I'm going to hit second mode. That's going to get me out of that screen. I'm going to go back to stat. And now what we need to do is calc. So what I want is the linear regression AX plus B. You can also use A plus BX just fine. It's just saying that the slope is B. And actually, let's go ahead and use that one since that's what we're doing so far. Either one works, just as long as you put your slope and your y-intercept in the right place. Let's go ahead and do this one. So I'll hit enter. It's going to ask me which list I want to use for my x or my explanatory variables and which list I want to use for my y or my response variables. We'd already set those up as being L1 and L2, and I'll hit calculate. And there we have it. So let's go ahead and write that out. It's not good enough just to put down these values. What we're going to need to do is actually write the equation of the line. So that's going to be y hat equals, b is my slope, right? So this is my slope. So it's going to be, and I can write it in this order. The order doesn't matter. So 2.829x plus a is my y-intercept. And remember, anything that's not touching an x, that's always going to be your y-intercept. So it doesn't matter if I write it in a separate order, as long as, like I said, you know what your y-intercept is, which is 300.040 if I'm rounding to the thousandths place. So there you have it. We've calculated the least squares regression line, or the equation of the least squares regression line, using summary statistics, it's easy for you to say, and using data. Those are the things we did. And we described how outliers affected the line. Hey, thank you guys so much for watching today. I hope you're having a fantastic day. And if you're not, man, I hope it gets better. Don't forget to take care of yourself.